Today we're going to look at exponential growth and decay. In order to get growth and decay, we got to take a look at our two formulas here. We need to understand what's going on here first. So now I have two equations that look very similar to each other. There's one small difference. One's got a plus, one's got a minus. One of these means exponential growth. The other means exponential decay. Okay, each one of these variables has a specific role. Our y is what we end with. Our a is what we start with. R is our rate or our percent that we start with, and T is time. Now the same thing goes for both of these. Now this parenthesis has a specific name as well. We call this the growth factor, and this one's called the decay factor. Okay, now we have all of our parts to this. Now we got to start picking out which one we're going to use. Most of these exponential growth and decay problems are going to start with a word problem. We just have to navigate through that. Start by reading it. A new car costing $30,000 initially depreciates in value by 15% each year. What's its value after 5 years? What's its value after 10 years? So a new car costing $30,000. There's our starting point. Okay, it initially depreciates. The word depreciates means goes down. So that automatically tells us we've got a decay problem. How much does it go down? It goes down by 15% each year. And what's that value after 5 years? So we have our formula, depreciates, uses decay, and we have our numbers that we need to plug in. So y equals what we're going to find. We start with 30,000, 1 minus 15% for 5 years. Now, I don't like something here. I don't like writing 15%. I want to write that as a decimal. So instead, we move that decimal 2 spots and we say 0.15. Okay, so we have our problem. We have our years. Now it's just order of operations. So we've got 0.85 raised to the 5th power. 0.85 to the 5th power gives us 0.4437. Multiply that by that 30,000, and we are left with $13,311. All right, after 5 years, the car still has some value. A little beat up, but we can deal with it. What about after 10 years? Well, let's get rid of some of this. The only thing we're changing now is that exponent to a 10. 0.85 to the 10th power now gives us 0.1968. And when I multiply these two things together, we're left with 5906. Yeah, your car's worth roughly about $6,000 now. I don't know if that's good or bad, but exponential growth and decay, we got to figure out what's what. So we have 2 questions, we have 2 answers, but it's just order of operations to get us through it, and that is solving exponential growth and decay.